Welcome to the APMM Virtual Conference 2021. We'd like to take a minute to highlight one of our excellent conference sponsors, Camera Graphics, based in Portland, Oregon. Camera Graphics specializes in a wide variety of graphics applications, including dry transfers, which owner John Zell also gave a workshop for earlier in the conference. Have a listen as John gives us an inside look at Camera Graphics and talks about what they do best.
Come on in. Welcome to Camera Graphics. My name's John Zell. My wife Christy and I have owned this business since 1996. Camera Graphics began in 1967 as what we would call a pre-press house serving the printing industries. Basically, what Camera Graphics has always done is produced film for uses in a number of different printing applications. So here's those applications. Here's a film positive and a silkscreen burned with that image for a screen printing application. Next to that is a film negative, and above it an offset printing plate, metal printing plate, and a printed job. So historically, Camera Graphics produced lots and lots of film negatives for offset printing shops. We also produce a film positive for pad printing. And this is a pad printing plate, or they call it a cliché. And above that is an item that has been pad printed, the same image. We also produce film negatives for letterpress printing. So here's your negative. Here is a letterpress plate and some examples of letterpress printing. Up here again, a negative, letterpress plate, and a printed letterpress job. And of course, since 2003, we've produced negatives for dry transfers. So you see in front of you a completed 3-color dry transfer sheet and the film negatives used to produce that sheet. And here are some examples of dry transfers applied to various parts made by a local model customer of mine. Here's some samples of the various types of dry transfers I've done. In the front here is silver and gold foil, PMS color match, some really fine detail. That's a 8-spot color dry transfer. 3-color logo, 4-color sheet. I actually do some transfers that are a combination of inkjet and standard dry transfer processes. And so these across the top are some full color dry transfers that then are backed up with white. So we can do some super fine detail if need be. Here's a multicolor job with some location marks around the edges that don't have adhesive on it, so that you can transfer on to a part and have the graphics fall exactly where you want it. Okay, this is a quick nickel tour of my production space for making dry transfers. On the right are my coating tables and developing tables. This is where we coat the various layers of a dry transfer. It is also where we strip off those layers as well. I have a light viewing booth and a computer in the back connected to a photospectrometer for color matching. In the back, you can see all of my ink inventory, the base colors that I use, metallics, fluorescents, lots of grays that I use over the years, and then Pantone colors that I've matched. This is my light source and vacuum frame that I use for exposing a film negative with the transfer sheet after it's been coated with photo emulsion. And then this is a washout sink that we use for rinsing away the unexposed emulsion. So that's it. Nice little space for doing transfers. I hope you can stick around and attend my dry transfer workshop. Thanks.
In today's session, we will be getting a detailed primer on electroplating with Michael Scribner, Senior Prototype Developer at Garmin. He will cover everything you need to know to get started with a step-by-step demonstration, including tips and tricks along the way. If you have any questions, Michael, as well as an APMM representative, will be available in the chat, and we encourage you to take notes and discuss techniques with the other attendees. The chat will be open until the end of the hour, and after the workshop has completed, we will have an open Q&A for the remainder of the time. And with that, let the games begin!
Hey everyone, I'm Michael Scribner, APMM Board Secretary and a Senior Prototype Developer at Garmin International. Today I'm going to tell you about a really cool, fast way to add real metal finishes to your prototypes, so stick around and let me introduce you to electroplating. First off, what exactly is electroplating? Electroplating is a general name for processes that create a metal coating on a solid substrate through the reduction of cations of that metal by means of a direct electric current. The part to be coated acts as the cathode, negative electrode, of an electrolytic cell. The electrolyte is a solution of a salt of the metal to be coated, and the anode, positive electrode, is usually either a block of that metal or of some inert conductive material. The current is provided by an external power supply. Sounds complicated, right? Big words, science. The principles behind it definitely can get technical. The good news is, from a model maker's perspective, we can achieve great electroplating results without understanding the science. Jewelers have been doing this sort of small-scale electroplating in the back rooms of their jewelry stores for decades, and most of them don't have chemistry degrees. Let's break it down to the basics. We've got a part that we want to plate. That's hooked to a negatively charged lead, and we call it the cathode. We have a positively charged anode. We stick these into a beaker full of liquid plating solution. Electrical current moves from the anode through the solution and into the cathode, completing the circuit. When this happens, positively charged metal ions in the plating solution are deposited onto our workpiece, building up a super thin but durable metal finish on our workpiece. Now that we know a little of the how, let's talk about the why. Why would we want to electroplate parts? Say a client wants a model to include some metal parts, and they want them to look like real metal. Maybe a brushed or fine polished finish, really fine details, in a gunmetal black or 24 karat gold tone. What are our options? There are spray-on finishes, paints that look like metal, but even the best of these tend to round over crisp lines and add a fair amount of thickness to the finished parts. PVD or vacuum metallization are options, but that requires big, expensive equipment, or outsourcing and waiting for the parts to come back, adding cost and time to your project. For some metals, you can machine the parts directly out of the metal in question, but that gets pretty expensive with something like gold, and we still haven't found a jet black metal. A small-scale electroplating setup can provide real metal finishes for you in-house. The process takes minutes, the finishes are durable, and add basically no thickness to your part. If your shop builds high-value prototypes where accurate finishes are critical, electroplating can be a powerful tool for you. Even if you outsource the plating, knowing a little about the process can be very useful in preparing your parts and knowing what to expect, so stay tuned. You can get started electroplating for a pretty low cost, as low as a few $1,000s if you're resourceful and willing to deal with more fuss work along the way. At the bare minimum, you need a suitable workspace, tools and equipment, plating chemicals, personal protective equipment, and a safe place to store chemicals when you're not using them. First off, let's talk about your workspace. It should be well ventilated, clean, and isolated from other shop activities and staff. For ventilation, you want a lab-style, mostly enclosed fume hood or snorkel-style system over or behind your plating baths, set up to pull the fumes away from you, not upwards across your face. The fumes should be vented outdoors, preferably on a roof or out a port, nowhere near people. You can get by with a fan at a window if you're really working on a shoestring budget. Just make sure the fumes are being pulled away from you and not going toward anyone else. You want your workspace isolated from coworkers, both for their safety and for yours. A cramped, chaotic workspace with others moving around in it can lead to distraction, mistakes, or accidents. You're dealing with glass beakers full of hot acid. Try to keep the distractions to a minimum. While we're always careful at our workstations, we all know that accidents do happen. When those accidents might involve hot acid in open beakers and electricity, a few precautions are in order. Make sure you have a dry chemical fire extinguisher in your plating area. Also, one of these chemical spill kits, just in case a beaker gets knocked over and you have a liter of acid running all over the floor. You don't want to clean that up with a roll of paper towels. As model makers, we can plan ahead to prevent accidents with a little shop hacking. Once you've gotten the hang of plating, and you have your space mapped out for your ideal workflow, use a little maker foo to tweak your space to make it safer. For example, in our plating lab, I've built a catch tray that covers the entire plating bench, so if a beaker does fall over, the acid-resistant tray will keep the solution from running off the table and spreading all over the floor. I also built a framework over the heat stations to hold all my beakers in place. With a frame like this, you'd have to try pretty hard to knock one of these over. To get started, you'll need a couple of controllable heat stations to warm your plating solutions. These can be as simple as a portable hot plate like this, to a purpose-built electroplating stand like this, all the way up to larger benchtop models like these. Of course, the bells and whistles get better the more you're willing to spend. Simple units just provide heat. Higher-priced models have real-time temperature control and magnetic stirring systems built into the base. Just make sure any unit you buy can control the temperature within 5 degrees Celsius increments. No matter what heat station option you choose, you'll need to be able to heat at least 2 beakers simultaneously, one for your electrocleaner and one for your plating bath. Now you could get by with 2 heating stations, but here's the thing. It's really best for you to move quickly and smoothly from one plating step to the next without downtime. Letting pieces dry out or sit around between plating steps increases the odds that something will go wrong with the plating, so you really want each bath to have its own heat source, not to be juggling beakers off and on a single heat source. For nickel plating, 2 heat sources is fine. If you plan to plate gold, I recommend you have 3, and if you're doing black oxide finishes like black ruthenium, you'll want 4. Now that you have heat, you need power. A rectifier is an adjustable power source that supplies DC current to your plating bath. A 3 amp or 5 amp rectifier will serve most of your needs. Plating processes use very low voltage and amperage in general. I'm typically not running over 3.5 volts for most metal finishes, and some run as low as 0.8 volts. Amperage is determined by the size of the workpiece, with large pieces drawing more amps than smaller ones. If you plan on doing Cli-R E-coating, you'll want a 50 or 60 amp rectifier, but I'll talk more about that later. There are a lot of options out there for plating solutions, as you'll see when you start shopping around. I get all our plating chemicals through Rio Grande Jewelry Supply and Ligor USA. These companies are both really helpful and great at answering questions about equipment or solutions. A quick search of either of their websites will give you an idea of just how many plating options and finishes there are to be had. Nickel, yellow gold, rose gold, black ruthenium, silver, rhodium, all sorts of things. Depending on how much plating you do and how clean you can keep your operation, a liter of solution can last you upwards of a few years. No matter what you're plating, you're going to need electrocleaner and acid dip. Electrocleaner is a strong caustic solution that chemically cleans your workpiece, and the electrical current running through it causes hydrogen bubbles to form, which perform a mechanical scrubbing action as well. Acid dip is used between plating steps to remove any residual plating acids. This makes sure your workpiece is clean as it moves through the baths, and helps prevent cross-contamination of plating solutions from one bath to the next. Both of these chemicals come in a dry, granular form, which you mix with distilled water. Suppliers offer it pre-mixed, but you'll save some money buying it as a concentrate. Unless you're investing in a plating station with plastic tanks, you'll want a half dozen 1-liter Pyrex beakers. These are durable, easy to clean, and you can see what's going on inside them while you plate. For every plating solution, you'll need a dedicated anode. Anodes are strips or bars of high-purity metal that pass current from the positive lead of your rectifier into the plating bath. In some cases, they also replenish metal ions into the plating bath. The surface area of your anode needs to be at least the same as the workpiece you're trying to plate. The 1" by 6" anodes available through most plating suppliers will be fine for most of the work you'll do in a 1-liter flask, though for larger pieces you may find a larger anode necessary. Keep a separate anode for your nickel bath, one for your gold bath, one for black ruthenium, etc. If you happen to have 2 baths that use the same type of anode, engrave the hang stem of each of them with the name of the bath, just to be sure they don't get crossed. Once an anode has been used in a specific plating solution, you never want to let it touch another solution, so pay attention while you're setting these up. As a general rule, use distilled or deionized water for any plating purposes. For years I've used these 1-gallon jugs of distilled water from my local neighborhood market, and they work just fine. Recently, our shop installed a reverse osmosis system to provide filtered water for our CNC mill's coolant systems. If you happen to have a system like this in your shop, great. It'll save you some time and keep you from lugging bottled water around. You'll use thin-gauge copper wire as a lead wire and for handling your workpieces while they're in the baths. 24 gauge is perfect, and a spool of it like this goes a long, long way. I'll show you how I fixed your parts with this later on when we're getting ready to plate. If plating solutions sit stagnant for too long, sometimes the dissolved metal salts will come out of solution and settle to the bottom of the beaker. Also, a moving solution helps prevent air pockets from staying trapped in nooks and crannies on your workpiece, which can lead to gaps in your plating. Glass stir rods are useful for stirring your plating solutions if you aren't using a heat station with a magnetic stir function. If you did purchase a heat station with magnetic stirring, these little ceramic-coated stir pellets will do the work for you. If your heat stations don't have integrated thermal probes, you'll need some durable stainless steel thermometers to keep an eye on the bath temperatures. Keep a set of copper or stainless steel tongs handy. You'll rarely need them, but if you happen to drop your workpiece into the bath, you'll be glad you have them around. Copper tongs are fine for most solutions, but a few will be contaminated by touching bare copper, so make sure you're familiar with the solutions you're working with. A timer is your best friend when trying to keep accurate track of your plating process. Plating times can run anywhere from 30 seconds to 10 minutes or longer, and having a timer really helps. You can use a clock, of course, or a kitchen timer, or your phone. Keep in mind that anything you touch in the workspace has a very real chance of getting plating solution on it, and rubber gloves can make it hard to fumble with the timer on your phone. Personally, I've found an Amazon Echo to be a great companion in the plating lab. I can tell Alexa to set a timer for me, hands-free, and she'll even play music or a podcast while I'm standing there holding a workpiece in ultra black ruthenium solution for 12 minutes. When you're justifying the Echo to your boss, just tell him it's for safety purposes and hands-free operation. Maybe don't mention the music or the podcasts. If you find yourself polishing a lot of parts, an ultrasonic cleaner can be a really useful tool for removing polishing compounds, or even just giving your workpieces a thorough final cleaning before the plating process. The most valuable piece of advice I can give you on plating is write down everything. Keep a journal of your plating activities. For every set of parts you plate, keep notes about what solutions you used, the voltage, time in the bath, everything. If something doesn't come out right, make a note of it. Keep track of the date that you open new bottles of solution, the date of each plating attempt. Take photos on your phone or quick sketches in your journal of how you fixtured the parts, what the parts looked like, and the dimensions of things. All of this is valuable. You can look back through your notes to find out what worked and what didn't. If your notes are thorough enough, you can even trace glitches in your process or track if a plating solution is going bad and why that might have happened. If you decide to reach out to a chemical or equipment supplier for advice or troubleshooting, having accurate information and photos can help them diagnose and offer suggestions. The plating chemicals we're dealing with are made up of strong acids, alkalis, metal salts, and other things we'd rather keep off of our skin, out of our eyes, and out of our lungs. Even in a safe work environment, things splash, heated chemicals give off vapors, stuff happens. When you're working with plating chemicals, wear an acid-resistant apron, lab goggles, chemical-resistant gloves, and a properly fitted N95 half-face respirator with chemical cartridges. When you're not using your plating chemicals, it's best to store them in a locked acid cabinet. Put them back in the bottles they were purchased in, or a chemical-resistant polyethylene safety storage bottle. If you switch bottles, make sure the new bottle is clearly labeled with the name of the chemical you're storing. Never leave these chemicals where untrained staff, kids, or pets can get a hold of them. When you're shopping for plating chemicals, you'll see some labeled as cyanide-based. These cyanide-based chemicals can have better working properties, particularly when parts have deep grooves or pockets that need plating on the bottom. But as you might imagine, cyanide is extremely poisonous, whether you get it on your skin or breathe in the fumes it gives off. To make matters worse, these solutions also complicate your hazardous waste generator status and disposal of chemicals, which we'll cover in more detail later. You can find far safer acid-based plating solution for any metal you want to plate. For your safety and the safety of those around you, stick to acid-based solutions. As model makers, we know how important safety data sheets are, and how important it is to be familiar with the chemicals we're exposing ourselves to in our shop environment. This is especially true of plating chemicals, which can be really nasty. The chemical suppliers will include a printed copy with every bottle they send you, and you can find the info on their websites in PDF form. Make sure you have physical copies of all the plating chemical MSDS in a labeled station very close to your plating operation, so first responders have access to them if an emergency happens and you're not able to answer questions. If you have a campus safety coordinator, they should have copies of all these MSDS as well. Of all the safety concerns associated with electroplating, disposal and regulation compliance can be the most daunting when you're just starting out, especially if you're a small business owner. This part of plating isn't fun, but it's very important and has to be given serious consideration before you decide if in-house electroplating is right for your shop. If your model shop is part of a larger corporate structure, you may have a campus safety and health department. If so, talk to your safety coordinator early in the process before you invest in any equipment or chemicals. Chances are they already have the training and knowledge to guide you through this part of the process. If your company does any kind of manufacturing on site, you'll probably already have all the necessary disposal processes and guidelines in place. If you run a small shop, you'll have to do more homework and familiarize yourself with the hazardous waste generator guidelines for your state or region. These guidelines vary from state to state, so I won't go into too much detail here, but at the very least they'll cover what counts as hazardous waste, how much you can produce in a year, and how to safely dispose of it. If you feel like you need more help or expert advice, you can reach out to a waste disposal or liquid waste management expert in your area. Your local environmental protection agency or Department of Health might be a good source for information on this subject. At a minimum, your bottles of plating solution are going to count as hazardous waste once they're plated out or contaminated. Once you can't use them anymore, they're waste. Depending on where you are, these restrictions may also cover your rinse water, any water you use to clean up your equipment, even your gloves, paper towels, anything that has plating chemicals on it or in it. Disposing of these waste products usually involves incineration at a regulated waste disposal facility. In order to electroplate a part, it has to be conductive. I find raw copper parts to be most practical. You can plate stainless steel too, it just adds a couple extra steps and solutions to the plating process. While aluminum is conductive, electroplating it is more work than copper. Aluminum oxidizes really fast, and the oxide that builds on the surface shields aluminum parts from our plating processes. It's possible, but involves extra steps and isn't very beginner-friendly. It's possible to plate non-conductive things by applying a conductive coating to the item before plating. Think bronze baby shoes, or those plated leaf necklaces you see at fall festivals or national park gift shops. The conductive coating is basically paint with silver or copper in it, so you can expect the part to gain thickness that will obscure fine details and sharp, crisp lines. Normally this is more of an electroforming thing, which I'll discuss later. One of the best things about electroplating is that the material buildup on your workpiece is trivial, a few millionths of an inch in most cases. The finish work you put on your part comes through to the final product after plating. You can polish it, bead blast it, put a scratch brush or sanded finish on it. Unlike paint or primer, there's no gap filling action here. This also means that you have to be meticulous about your surface prep. Any imperfections you leave on the part are going to show after it's plated too. Once you're happy with the surface finish, attach the workpiece to a short length of 24 gauge copper wire. Your handling wire should be long enough to hang your workpiece halfway into the 1 liter Pyrex beaker while giving you a few inches clearance between the top of the beaker and the alligator lead clip on the cathode. For really small parts, you can even put a couple of pieces on the same handling wire in order to save time in plating. The wire should not be touching any part of the workpiece that has to look good on the finished project, because you'll usually get a discoloration or partial plating at these contact points. While most parts are okay with a single contact point, you'll run into certain shapes that require more points of contact in order to get a good current flow across the whole piece. Make certain that the workpiece can't fall off of the handling wire once it's in the plating bath. If this happens, you're going to be stabbing around in hot acid with metal tongs that are almost certain to scratch and scrape the finish work on your parts. Save yourself the headache and make sure the part is securely fastened to the handling wire. Personally, I like my handling wire to have some stiffness to it, as I find it makes controlling the workpiece in the bath a little easier. I use enough wire that I can anchor the workpiece at the middle of the strand, double the wire over on itself, and twist the loose ends together with a pair of fine pliers. Once I've built up a little bulk at the end of the wire, I chuck it up in an electric drill, hold onto my workpiece securely, and slowly twist the wire, creating a twisted handling wire. The little bird nest of copper at the top of the handling wire also gives the rectifier lead clip something to securely grab onto. Figuring out how to fixture your parts takes practice, and sometimes you'll have to get creative depending on the shape of the part. It helps to consider fixturing before the parts are even machined, because sometimes you can add a boss, groove, or hole in an inconspicuous spot on the part in CAD and let the CNC do the work of creating the fixture points for you. At this point, your parts are almost ready to plate. The last thing we need to do is a thorough scrubbing with some soapy tap water. Dishwashing liquid works just fine for this. Make sure that whatever brush you use won't scratch up your workpieces though. Natural fibers or nylon are fine for this step. If you have a lot of polishing compound built up on your parts, you may find an ultrasonic cleaner useful here. They do a great job of breaking up polishing residues in hard-to-reach spots on your parts. Personally, I use water-soluble polishing compounds and almost never need ultrasonic cleaners. Soap, water, and a hand brush are usually good enough. Before you move on to plating, there's a simple test you can do to ensure your parts are clean enough. It's called a water break test, and it'll tell you whether there are any oils, residues, or materials left on your workpiece that may prevent plating from going smoothly. Either dip your part into a cup of clean tap water, or run water over the part. The part should be uniformly wet after being submerged or doused, and the water should run off of the part in a uniform layer. If the water breaks into small drops or won't coat certain areas of the workpiece, the part probably isn't clean enough. Ideally, I try to handle all the finish work on a few parts at a time, then move straight into plating, never leaving the parts sitting with raw copper exposed for more than a few hours. Obviously, this isn't always practical, and sometimes your parts will start to show surface oxidation. It's annoying, and it will definitely affect your finished plated parts, but we have a couple very easy ways to deal with this. First, I recommend using these anti-tarnish tabs. You can buy them from jewelry supply companies. They're sort of like those bags of silica beads you find in boxes to keep moisture out, but these little guys prevent oxidation instead. Just seal your workpieces in small plastic bags with one of these and they should be fine for a day or two. Now if your part does show some oxidation, that's not really that big of a deal either. Keep a few bottles of liquid tarnish remover handy. I personally recommend Tarnex. Pour this into a beaker and dip your workpiece in it before you begin the plating process. Unless the part has serious oxide buildup, a few seconds in this stuff will have your pieces sparkling and ready to plate. Make sure the tarnish remover you buy is a low viscosity liquid, not a gel or a paste. We're almost ready to plate, but first we need to get our baths ready. It'll take about half an hour for your baths to heat up, so plan ahead. Before you get started, remember to put on your personal protective equipment. One at a time, take your plating chemicals out of your secure storage location. Carefully pour each solution into a Pyrex beaker and place the beakers onto your heat sources. If your heat stations have thermal probes, lower them into the beakers, close to the edge and away from where you plan on placing the anodes. Add magnetic stir pellets if your heat sources have stirring mechanisms in the base. Bring the baths up to the listed temperatures. For each bath, set up a beaker of distilled water next to it. You'll use this as a dedicated rinse tank for that plating solution. You'll need these for your acid dip and electrocleaner too. It's very important that you don't mix these up, as you might cross-contaminate baths if you rinse in the wrong tank. When I was starting out, I found it helpful to label each beaker with masking tape and write the name of each plating solution on the outside, with a label for each rinse tank to match. Activate the magnetic stir function if you have it, set it to about 250 RPM. This is a good, gentle speed for your baths that keeps things blended and moves the liquid around the workpiece well. If you don't have a magnetic stir station, just stir the liquid with a glass rod every now and then between processes or when you notice sediment in the bath. Place your anodes into the plating baths, then attach the anode lead clips. If you only have one rectifier, you'll have to switch the anode clip from anode to anode as you go through the plating steps. Power up the rectifier and adjust the voltage to your desired setting. For safety reasons, it's best not to leave the rectifier on unless you're nearly ready to plate. Once all this is done and the baths are at the proper temperatures, you're finally ready to do some plating. Starting with a clean workpiece on a copper handling wire, wet the workpiece by submerging it in a distilled water bath. You'll be returning to this bath often, and we'll call it our clean water rinse tank. It's a good idea to change this rinse water regularly, at least once per plating session. Attach the handling wire to the cathode clip for your electrocleaner bath. If you haven't already, turn on the rectifier and set it to 6 volts. Submerge the workpiece and slowly rotate it in the bath, exposing all surfaces to the anode with slow, steady motion for about a minute. Remember not to let the workpiece come into contact with the anode. Remove the workpiece from the bath. Remove the cathode clip from the handling wire, then submerge the workpiece into the electrocleaner rinse tank. Submerge the handling wire at least as deep as you had it in the electrocleaner bath, in order to make sure you rinse off as much of the electrocleaner solution as possible. Switch the workpiece around a bit, then remove it from the rinse tank. Rinse your workpiece in the clean water rinse tank for a few seconds. If any residue from the electrocleaning step remained on the workpiece or handling wire, this second rinse should remove it. Submerge your workpiece into the acid dip solution. Swish it around a bit, and leave it to soak for 30 seconds to a minute. The acid dip neutralizes any residues from a previous step and maximizes plating adhesion. Remove the workpiece from the acid dip. Submerge the workpiece in the acid dip rinse tank, and follow up that rinse with another rinse in the clean water rinse tank. Now, whether you're aiming for a nickel finish, gold, black ruthenium, or just about any other plated metal, your next step is a nickel plate. That's because nickel serves as a barrier metal for the copper underneath. Without it, your copper base part will quickly alloy itself to the gold, silver, or whatever else is above it, and you'll start to get oxidation and discoloration of the finished layers. Let's walk through the nickel process, which will sound pretty familiar. It's the same as the electrocleaner, just with different settings. Attach the handling wire to the cathode clip for your nickel bath. Turn on the rectifier. For small parts, 1 volt is a good starting point, though some very small parts might go as low as a ½ volt, and heavier or larger parts may go as high as 4 volts. Submerge the workpiece, shaking it gently for a bit, then start slowly rotating the workpiece. Keep the part centered in the beaker, never going too close to the anode. Keep this up for about a minute. Remove the workpiece from the nickel bath. Remove the cathode clip from the handling wire, then rinse in the nickel rinse tank. Swish the workpiece around a bit, then remove it from the rinse tank. Rinse your workpiece in the clean water rinse tank for a few seconds, then remove it. Acid dip the workpiece for 30 seconds to a minute, swishing it around gently. Remove the workpiece from the acid dip. Submerge the workpiece in the acid dip rinse tank, and follow up that rinse with another rinse in the clean water rinse tank. And one more time in 24 karat yellow gold solution. Hook up to our cathode clip. Set our rectifier to 3.5 volts. I found this setting to work pretty well for tiny parts all the way up to a few inches across. It's a good baseline to start from. Submerge the workpiece, shake it gently, then start slowly rotating it, exposing the whole surface of the part to the anode. Still making sure not to come in contact with the anode, not getting too close to it. Keep the workpiece in the gold bath for about 90 seconds. Remove the workpiece, unclip the cathode clip, rinse in the dedicated gold rinse tank, then the clean rinse tank. Acid dip the part for 30 seconds to a minute, then rinse in the acid dip rinse tank. Give the part another rinse in the clean rinse tank. There you have it. If you followed those steps in each process, you've got the basics of electroplating down. The rest is mostly just figuring out the settings for your specific parts and applications. That all comes with experience. Now you might think all the rinse steps seem sort of redundant. In a way, some of them are, but let me clarify what we're achieving by having a dedicated rinse bath for each plating solution. Each time you pull a plated part out of the plating solution, you're bringing some amount of plating solution with it. This hitchhiking material is referred to as drag out, and nearly all of it ends up being dropped off in your dedicated rinse tank, dispersed into the rinse water for that solution. As you work, over the course of hours, the heated plating baths will slowly lose water to evaporation. What we're going to do is take our dedicated rinse tanks and top off our plating baths with the rinse water that's dedicated to that plating solution. By doing this, we're taking the drag out, all those nasty chemicals, metal salts, acids, and alkalis, and we're putting them right back into the plating solution along with the water we need to keep the baths topped off. By trapping the drag out and recycling it into the baths as we top off, we're cutting the hazardous waste generated by our wastewater down to nearly zero. The amount of chemicals that make it to the clean water rinse tank are so much lower than they would be if we weren't using dedicated rinse tanks. Is it fussier than just using a single common rinse tank? Yeah. Personally, I believe the extra steps are worth the effort in the name of keeping my operation as clean and waste-free as possible. I hope you will too. Once you've finished plating a part, give it a final rinse of distilled water from a squeeze bottle, letting the excess water fall into your clean water rinse tank. From here, you can either hang the part to air dry it with a soft cloth, or blast it with some pressurized air to dry it off quickly. If you're done for the day, turn off the rectifiers and heat sources, and let the plating solutions cool down. Again, the magnetic stir stations come in handy here. The solutions will cool faster if they're being stirred, particularly at high speed. Fill a bucket with some tap water and throw in some baking soda. As you put away your chemicals and break down your tools, you'll be throwing your beakers, tongs, and anything else in here that got plating solution on it or in it. The baking soda will help neutralize whatever trace amounts of acid are left over, though if you're using dedicated rinse tanks, there should be basically no residual plating chemicals making their way here. Pull the anodes out of the plating baths and dunk them in the dedicated rinse tanks to collect as much of the drag out as possible. Hold them over the dedicated rinse tank and squirt some distilled water over them, giving them one final rinse to catch every bit of drag out that you can, letting the water fall back into the proper rinse tank. Place the anodes into the cleaning bucket. After the plating chemicals have cooled down to a safe level, slowly and carefully put them back into their specific safe storage bottles using a chemical-resistant plastic funnel to prevent spills. Afterward, store your plating chemicals in their safe storage location, preferably under lock and key. Store your dedicated rinse waters the same way, in their own well-labeled bottles. Place the beakers, funnels, and stir pellets into the cleaning bucket. Once you've collected all the tools and containers you used, you can clean these with simple tap water and dish soap. Some heavy scouring pads will be useful for keeping pure metal anodes clean, and kitchen bristle brushes are good for everything else. Make sure that any tools used for cleaning plating equipment are only used for plating equipment and clearly labeled. Whether or not the cleaning water is considered hazardous waste will depend on your state or region's hazardous waste generator guidelines. If it is, you may have to do your cleaning in a bucket, or have a shop sink that drains to a storage tank rather than municipal sewer lines. Some way to catch this water and store it for proper disposal and to ensure it doesn't make its way into public sewers. Plating solutions come with dissolved metal salts in them. This is where the metal ions come from that plate your parts. As you use the solution, these ions are slowly depleted, which throws off the chemistry of the bath. Once this starts, your parts will not plate right and will look hazy or pale. Some solutions can be restored by adding a small amount of a specific brightener. Check with your chemical supplier for these. Your chemicals will pick up organic matter just from existing in your workspace, exposed to open air. Given enough time, you might even notice mold or other bizarre things growing in the bottle. You can filter your solutions with a coffee filter to get rid of these organics, and it's a good idea to filter the solutions every few months just to get rid of the stuff you can't see. An easy way to do this is to take a spare Pyrex beaker and cut a wide hole in the plastic lid. Basically just remove that area inside the handle. Stick the coffee filter in the beaker, then use the lid to hold it in place. Slowly pour the plating solution through this filter, and you're good to go. For most model makers, the steps I've outlined above will cover most common electroplating applications that we need in our shops. But I want to briefly touch on a few more things you can do, just so you know the options exist. Electroforming is a similar process to electroplating, except you run the bath at a very low amperage for a long time, up to 12 hours or more. Usually this is done with copper, and you can build up a very thick shell of copper over a base part. This shell can be nearly 1/3 of a millimeter thick. One use of this process might be to form a solid copper shell over a wax pattern, then melt the wax out for a solid metal object that's also very light and hollow. It can also be used to build up a cast metal part that shrank in the mold, or to help fill in surface porosity on a cast part, or for making those bronze baby shoes or leaf necklaces that we talked about earlier. Ligor sells a line of plating pigments referred to as Clyar Nanoceramic E-coating. This process allows you to add bright colors to metal parts while retaining the shine, texture, and feel of the metal beneath. It's sort of like powder coating, but with a very low build translucent paint. This process requires a high voltage rectifier, so if you only plan to purchase one rectifier for plating and think you might be interested in adding Clyar, make sure you buy a 50 or 60 volt rectifier. You can use it for all your standard plating purposes at lower voltages, and you'll be able to crank it up when you need it for Clyar work. You'll also need a small curing oven to cure the finish. Most suppliers of plating equipment also offer pen plating systems, which are basically the same idea, just miniaturized to use a stylus and a small amount of solution concentrated around the tip of the stylus to allow you to draw a metal plate on specific portions of a conductive object. You can use lacquer-based paint as a resist for electroplating. After you've finished plating, lacquer thinner will strip the stuff right off and won't harm the plated finish. This can be handy for two-tone effects. So now you've seen how the sausage is made, and you have a better idea of what's involved if you want to do it yourself. So now the question, bring electroplating in-house or outsource it? There is something to be said for letting an outside expert handle this work for you, especially if you only need it done occasionally. Let them deal with the safety issues, the capital investment, and the hazardous waste disposal. Maybe you see value in the process for your appearance models, but just don't have the time to learn a new skill. But finding a good electroplater can be challenging depending on where you're located. Some of the larger outfits won't want to deal with one or two parts at a time, or may not offer the metal finish you're looking for. They may only run a particular finish once a month, and you're stuck waiting on their timeline rather than yours. If you can't find any dedicated plating shops in your area, I recommend looking for small, locally owned jewelry stores. The big chains don't typically do plating in-house, but some of the small shops will. Jewelers are going to be very attentive to fine detail. They realize the importance of maintaining your finished surfaces, and they're used to working in small quantities of highly valuable parts. In our case, we spent a few years trying out local plating shops with very spotty results. We'd go through the trouble of setting up a vendor, getting NDAs signed, delivering finely finished parts to the plater, only to get them back a week later with scratches on them, blisters on the plated surface, discolored plating, and so on. Who has time for that? That lack of control over the process for our most important models was what made us decide to bring electroplating in-house. There are a lot of advantages to doing it yourself, for sure. No messing around with NDAs or privacy issues with outside shops. When you do the plating, you know the parts will be taken care of from start to finish. You always know what plating solutions are available to you, and never have to worry about finding a shop that is willing or able to plate the finish you want plated. Finally, it's just so much faster than shipping parts to a shop halfway across the country, or even driving across town to deliver parts to a local shop, waiting for them to do the work and get the parts back to you. If you own the equipment and have your processes down, you can have plated parts in an hour, and that's including warm-up time for the plating baths. So we come back to the question, do you plate in-house or outsource? I've given you some things to think about, but only you can answer that question for your shop. So that's electroplating for you. As I'm wrapping up, here are a few key points I hope you'll remember. Do your homework. Before you dive into this, make sure you research the safety and disposal considerations. Download the MSDS for all the chemicals you plan to use, study them, and consult with a local hazardous waste professional or your campus safety coordinator. Stay away from cyanide. At least while you're starting out, don't buy or use any cyanide-based plating solutions. The risk is just too high, and in most cases you're going to do just fine with acid-based plating solutions. When you're ordering chemicals, make sure they send you the right ones, because most plating suppliers won't accept returns on solutions. You don't want to get stuck with a liter of cyanide solution that you don't want to use and now have to pay to dispose of. Work safe. Make sure your space is well ventilated, and wear all the PPE we discussed. Work clean. Most plating problems come down to a part that wasn't clean enough or a plating bath that's contaminated. Avoid these sorts of problems by working clean, following steps in the right order, and filtering your solutions every now and then. Change out that clean rinse water often, and use those dedicated rinse tanks for each solution. Take notes. Take notes on everything you do in the plating lab. Have a notebook handy and keep a journal with all your plating work documented. Note your settings, make sketches, take pictures with your phone, and keep them in a reference folder. This will help you in so many ways. You can refer back to old projects in case you have a similar job come up in the future. You can track how baths are performing or errors that keep popping up, which may help you troubleshoot along the way. Finally, I want to thank you all for taking the time to watch and learn with me. We'll have a live chat running for the rest of this session, and I'll be happy to answer questions in the chat as long as there's time. If you have any questions after that, or you're coming to this video after the conference, you can find me over on the Association of Professional Model Makers forum at modelmakers.org. If you're an APMM member, you can find the Electroplating forum and ask me any questions you have, and I'll do my best to help you out. Thanks again, and enjoy the rest of the conference.
And now on to the Q&A. If you haven't already, head over to the chat, either to your right if you're viewing on a desktop, or below if you're on a smartphone, and join the discussion with the presenter and your fellow model makers. When you are ready, or after the session ends, you can head to the APMM Zoom meetup for further discussion or general information from an APMM representative. This Zoom meetup will be open all day from 9 a.m. to 9 p.m. Eastern Standard Time. For future sessions, head back to the conference schedule page for dates, times, and the appropriate link for each session. And as you discuss, we want to thank the companies and individuals that have supported the APMM and our conference efforts with their donations after we had to postpone our in-person conference last year. Your support means a lot to this organization, and it helped make this conference a reality. Find the names of our amazingly generous conference donors on the screen now. Thanks for coming to this session. We hope you enjoyed it.